right, hi, this is Ms. Schuler again. Here is our second lesson on matrices. We're going to be talking about determinants and inverses of 2 by 2 matrices. Now remember, when I say 2 by 2 matrix, what I mean is that the matrix has 2 rows and 2 columns. So first, let's talk about what a determinant is. A determinant of a matrix is always going to be a single number, and there is a rule for 2 by 2 matrices to find the determinant. To find the determinant of a 2 by 2 matrix, you would basically label each term, each element with an A, B, C, or D in this specific order, and then the determinant is A times D minus B times C. Now you'll notice here that it looks like that instead of a regular matrix, it looks like it's in absolute value bars. And when it's in an absolute value bar, that is the symbol for determinant. So for example, number 1 here, we know that we're finding the determinant because the matrix is in absolute value bars, and we do A times D, 5 times 2 minus B times C, 3 times 4. So we get 5 times 2 minus 3 times 4, which is 10 minus 12, which is negative 2. Same thing here for example 2. We've got A times D minus B times C. Negative 1 times 3 minus negative 4 times 0, which is negative 3 minus 0, which is negative 3. Now on the next example, we've got again A times D, 6 times 2, minus B times C, 4 times 3. What ends up happening here is we get 12 times 12, which is 0. Now let's remember example 3, determinant being 0, because that's a special case. The determinant can be any number. It can be a positive, a negative, or 0, but there's something specific that happens when it's 0, and we'll talk about that in a little bit. Our final example here is example 4. Again, A times D is 3 times 7. 10 times 2, B times C is 10 times 2, so 3 times 7 minus 10 times 2 is 21 minus 20, and so the determinant here is 1. So what I want the directions to be here are to find the determinant of each matrix. So go ahead and pause the video here, and using your notes, go ahead and find the determinant for these 3 practice problems. Okay, hopefully you've gotten a chance to go ahead and try that. Here are the answers to those 3 practice problems for finding the determinant of each of the matrices. So for the determinant for letter A is 17, matrix B is 0, and matrix C is negative 4. So the question is, why do we care what a determinant is? What is the purpose of finding a determinant? And the purpose of finding a determinant is specifically, or at least one of the uses, is to find an inverse of a matrix. And so that is what we're going to be using determinants primarily for in this unit, is to find inverses of matrices. So again, we're going to be talking today about a 2 by 2 matrix, and so we have the steps listed there to find the inverse of that 2 by 2 matrix. So first thing we need to do is find the determinant, and then we have our same matrix A, B, C, D. We're switching A and D, the locations of the elements, and then we're going to keep B and C where they are, but change their signs. So if they were positive, turn it negative, negative, turn it positive. And then finally, we multiply our new matrix with the A and D and B and C changed by 1 over the determinant. And so the rule is here to the right-hand side. So this is our original matrix. We know that we're trying to find the inverse because it has an inverse symbol, which looks like an exponent of -1. And we've got 1 over the determinant times our new matrix, where A and D are switched and B and C's signs have changed. So let's talk about a couple examples. So we've got the first thing I'm going to do here is I'm going to find the determinant. 8 times -1 minus 5 times -2, A times D minus B times C. When I do that, I get -8 plus 10, which is 2. Then, to find my inverse, I do 1 over the determinant, 1 over 2, times my new matrix, where A and D have switched positions, and B and C have changed signs. And then I multiply everything in this new matrix by 1 over 2. And I do that, and I get -1/2, -5 halves, 2 halves, and 8 halves, which some of those can be simplified. So our final answer for the inverse in example number 5 is -1/2, -5 halves, 1, and 4. And that's our matrix. We can do the same thing for example 6. We first find our determinant, A times D, 3 times 5, minus B times C, 8 times 2. We get 15 minus 16, which is -1. To find our inverse, we do 1 over the determinant, 1 over -1, times our new matrix, where A and D have switched places and B and C's signs have changed. And then 1 divided by -1 is -1. So we are just multiplying all the elements of our new matrix by -1. So final answer here for the matrix, or the inverse of the matrix in example 6, is -5, 8 to -3. On this next page, we have some more examples here of finding the determinant. I'll let you guys pause the video and look over these yourselves. If you'd like to try them first, you can. But the one thing that I would like to point out before you guys get started with that is at the bottom, a square matrix does not have an inverse if the determinant equals 0. Okay, so remember, this is the special case that we were talking about in example 3 earlier. If you do have a determinant that equals 0, then that means you do not have an inverse for that matrix, because when we're trying to find the inverse of a matrix, we do 1 divided by the determinant. We know that we're not allowed to divide by 0. So if you have a determinant of 0, then you would not be able to divide by that value. And so the inverse does not exist. And so that is what happens in letter C here. So go ahead, maybe pause the video, try the others, and then check your work. All right. Now for the practice section at the end here. The key thing is, and we talked about this earlier in the notes, that when a matrix looks like it's an absolute value bars instead of a regular matrix shape, with sort of the bars, with the ends, it is asking you to find the determinant of the matrix. So the whole first section of this practice here is not asking you to find the inverse, they're asking you to find the determinant, because they're all matrices in absolute value bars. You know you need to find a determinant when it looks like that. You know you need to find an inverse when it looks like a regular matrix, but with something that looks like an exponent of -1, which is of course our symbol for inverse. So again, I'm going to ask that you guys, and suggest that you pause the video and go ahead and try the problems. There are answers on either the bottom or the last page of your notes, depending on what you're looking at. Or on it'll be at the end here. But try it yourself first and then check your answers. All right, so here are the answers to all of the determinant questions. So go ahead, take a look at those answers, see how you did. All right, and then here are the answers to all of the inverse practice questions at the bottom. Again, to find the inverse, you first find the determinant, then multiply 1 over the determinant by the new matrix, which is found by switching the elements in positions A and D, and switching the signs of the elements in positions B and C. And all of the information that we've talked about today is specific to a 2 by 2 matrix. This is not in general, but everything we've talked about is specific to a 2 by 2 matrix. All right, and this last page has just the answers if you jumped here. That is it for determinants and inverses of 2 by 2 matrices. You should now have everything you need to complete your assignment on matrices, on Delta Math. Good luck.